and I'm going to be going over IP subnetting in regards to networking. So let's proceed with the problem as requested by Henry. So let's go full into it. So basically, let's look at the question. So we're given an IPv4 address, and it's in CIDR notation, and we're identifying the subnet IDs. So the 4 subnet IDs. Okay, so we have the /26 network. So essentially what that means is let's first see how many subnets we're actually going to need, even though it tells us we have 4 right here, but let's proceed with it anyways. So essentially what we need to keep in mind is we need to have a basic understanding of what an IP address is. So let me go ahead and write that down. So what is an IP? Like, what can it contain? So it's essentially going to be, it's going to have bits of 32 in total, okay? And what else is it going to have? It's going to have four octets. And what are each of those octets going to contain? They're going to contain essentially 8 bits per those octets. So this is going from top down, and we could easily visualize what's going on. So let me go ahead and show you what's going on. So in pink right here, you could see this is octet number 1, octet number 2, octet number 3, octet number 4. Now in blue, each of these octets they're going to have 8 bits per octet, and we're going to see that in once we convert this to binary. And essentially in total they're going to be 32 bits. So let's convert it to binary. So essentially, what we're going to do is we know we have 26, -26 network. So what that means is we're going to have 26 1 values. So 26 ones, and so we know it's 8 bits per octet. So we're gonna do it like proceeding that way. So 8 ones, and then another 8 ones, and another 8 ones. So 1, 2, 3, 4, 5, 6, 7, 8. So this is our first octet. Now we're going to have another octet of all ones. 1, 2, 3, 4, 5, 6, 7, 8. So here's our second octet. So this total is 16. 1, 2, 3, 4, 5, 6, 7, 8. So now there's 24 bits. And we need 26. So we're going to need how many? 2 more bits. 1, 2. And we need to have 32 in total, so we're going to have to fill these with 0 values. So the -26 means we have 26 ones, essentially, and then the rest we're going to fill with zeros. So 2, 3, 4, 5, 6, 7, 8. So essentially what you're looking at here is our netmask binary. Okay, and now let me go more into it and show you how what it's composed of, essentially. So we still have these let me go in pink. We still have these 4 octets. And what are these octets composed of? In blue, I'm gonna show you that these are each composed of 8 bits. So each of these ones are 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. So all of these are 8 bits. And in total, these equal 32 bits in total. So as a whole, they're all 32 bits. This is something you should know about IP addresses, all right? So now let's look into what we could do with this information. So essentially, now that we have the netmask binary, we're going to determine how many subnets there are. So over here in the problem, it tells us that we have 4 subnets. But what could we? Let's just double check and verify that there are, in essence, 4 possible subnets. So the formula for that, I'm going to write it down right here. So essentially, it is 2 to the power of number of basically our number of subnet bits. So how many subnet bits do we have? So let's put that right here. How many subnet bits do we have? So in pink, our subnet bits, I'm going to show you right here. It is the remaining ones. So subnet bits are the remaining 1 values. So we have 2 remaining 1 values. So 2 to the 2 power equals 4 And this 4, what is it? This is our number of subnets. So possible subnets. So let's verify this. So we didn't really need to do this step, but it's good to do because it shows us that how many subnets we have. So over here, all of these, let me highlight it in dark blue. So we have 1, this is our first subnet, 2, 3, and 4. So all our answer choices essentially have 4 subnet possible, and it even tells us in the problem we have 4 subnets. So this is how we verify that we do have it indeed. And if it were a different problem and there was a disparity between the different subnets, we could easily narrow it down to a plausible choice. So now that we've done this, let's proceed with actually solving, actually getting more in depth and solving the problem. So what we're essentially going to want to do now is look back to what's given to us in the problem. And what's given to us in the problem, we have the IP address. So let's utilize that IP address and see what we could do with it. So let me write down the IP here, 215.200.110.50. So let me make it a little bit longer, okay? So this is the IP we're given, okay? And let's compare it to our netmask binary. So in green, I'm going to show you what is valid. So 1 is the true, so we're going to keep this the same. This is also all 1s, we're going to keep this the same. These are also all 1s, we're going to keep this the same. The only disparity is in this last octet. So we know that in this last octet, this the 50, that's what we're gonna need to find out essentially. So this 50 right here is what we're gonna need to find out, and we're gonna convert this 50 right here into we're gonna convert it to a binary. So convert this to binary. So B for binary. So how do we convert numbers into binary? So I'm sure all of you remember this from earlier courses. So converting something to binary, we're essentially going to start off with, the 1, and then it's going to be a 2, and then it's going to be the 4, and then it's going to be the 8, and then it's going to be the 16, 32, 64, 128. So I know it looks a little messy now. Let me organize this. So let's convert. We're converting the 50 to a binary. Does 128, does that go into 50? No, it does not go into 50. Does 64 go into 50? No, it does not go into 50. 32 does go into 50. And 16 does go into 50. So this 32 and the 15, my bad, this 16, this 32 and 16, that's going to give us a 48 if we add them. And what is this 8? That does not give us a 50. A 4 does not give us a 50. A 2 will give us a 50, so 48 plus 2 will give us 50, and the 1 will not. So we're essentially converting this to binary. So now let's actually do the conversion on top. I'm going to do it in pink. So whatever there's an X, we're going to put a 0. Wherever there's a check mark, we're going to put a 1. So 0, my bad, 0, 0, 1, 1, 0, 0, 1, 0. Okay, so this is essentially our binary. I've noted that by B. Okay, so there's a little arrow for our binary. Okay, I'll just keep it like this. So now that we have our binary, what are we going to want to do with it? So we're going to want to compare it with our last octet. So this octet where I'm pointing to right here with the pink arrow, we're going to want to compare this and this this binary. So let's do that. I'm gonna put a text right here. We're gonna put the net binary, which is equal to, what is the netmask binary? That would be up here where I put the first arrow to. So that would be 1, 1. That is our netmask binary. And then what is the other one? The other one is the 52 binary. And what does that give us? So we have 1, 1, 0, 0, 1, 0. And then everything else, we're just going to leave it with zeros. These two remaining ones is just going to be zeros. So now we're going to have to do multiplication. So the x is multiplication. So binary multiplication. So how do we multiply these now? So we're going to have to do binary multiplication, and it's fairly simple. So essentially, the 1 times the 1 would give us a 1. What would the 1 times the 1 give us? A 1. 0 times a 0 would give us a 0. 0 times a 0 would give us a 0. 0 times a 1 would give us a 0. And 0 times 0, 0. 0 times 0, 0. 0 times 0, 0. So now we have this binary right here. And I've circled it in pink. What we're going to do essentially now is we will convert this binary to decimal. So D for decimal. And we're going to look at each of these places. So remember, this is the 1's place. This would be the 2, the 4. So we're going to just do that and get the decimal value. So 1, 2, 4, 8, 16, 32, 64, 128. So these last two values are 64 and 128. So what is that summation give us? That gives us 192, right? And if we look at our answer choices for one of our subnets, we see that in our fourth octet, 192, and all the other octets are this octet was constant. So we have this 192 and this 192 right here. So this is our answer choice. Our answer choice is C for this problem. So thank you. If you guys have any questions, please let me know, and thanks.